Athan, welcome to Chewing It Over. Why should we measure stuff in MSK anyway?
Actually, it's because if you can measure it, then you can improve it. That's one reason. And the second one is you have to build motivation with your patients, right? It's important that they engage so that they follow up with their rehab to the end.
Now, that's really interesting because that second point is one of the things that's part of the origin story of Kinvent. Like you were inspired by that as an athlete and patient, and you felt like your motivation faded if it wasn't measured. So just tell that story for me, if you would.
Story is that I did 10 years of competitive sports, rowing and rugby. And actually, thanks to my favorite sports, I spent more time with my physical therapist than with my, let's say, coach or
Right.
true. I mean, knees, ankle, anything. Not very serious ones. I mean, I never had an injury, but every time it was a set of, let's say, 10, 20 therapy sessions, right? Physical
Okay.
therapy. And every time, after 3 sessions, I just wanted to abandon and go do it by myself at home. You have the impression of playing with elastics and gym balls in a gym by yourself. You don't know why you're there. You don't see your progress. It seems boring. And I'm an engineer myself. And, professors and teachers always told me, Athan, you have to base your decisions on facts, numbers, and curves. And there was none.
Right.
So this started as a frustration. And after I actually stopped my sessions, that was also frustrating for my physical therapist, of course, right?
Okay. Okay.
You guys, physiotherapists, you love your work. You are among the most passionate people I've met for their work. I mean, if you just leave two physios together by themselves and in a group of people, they will turn to each other and start discussing about the ACL they treated the other day and what kind of test they did and that kind of stuff. So
Yeah.
the why behind Kinvent is to build a system that will help both those guys, the patients and the practitioners, so that you
Mhm.
can measure progress, but most importantly, build engagement. And that's why you need to measure it.
And so what's really interesting is that your hardware and software really seem to speak to that dual aim, which is great because the usability and the precision have been really crucial to what you're doing. So tell me about the engineering problem solving part of you that then was inspired to drive building what you've built.
So the whole story starts when I was very, very, very young, because actually my dad was a biomechanics professor. Now
Right.
he's retired, he's happy with his 4 or 5 grandkids. But at the time, when I was very, very young, like let's say 1 or 2 years old, I was in his lab and he was building his own sensors because he didn't have any budget back in Greece. So this is where biomechanics started for me. And this is where I learned the basic stuff. And then I did some engineering studies because I always wanted to build something for, let's say, athletes. And then
Right.
my physical therapy experiences helped me to go towards that path. So the idea was, how can we use this science, biomechanics, to give insights that practitioners, but even more patients or athletes understand. So the way we try to build our system is that is scientific, so it measures the right thing, but also the interfaces are made in a way so even your patient, I mean, let's say Grandma Michelle, for example, she comes in for her hip surgery. You want her to understand why she's there. You want her to understand why her strength on the hip extension, for example, is growing, right? So that's what does she want? She just wants to walk back again and get her grandkid in her arms.
And I think that that's one of the things that's particularly interesting as I've got to know the company, as I've got to know you a little better. The engineering, sort of the physics of the matter, the numbers of the matter, the measurement, the precision, that is rarely embodied in the same person that's also got a passion for the individual humans, right? I know I'm speaking to cliches a little bit there, but sometimes that it's reasonable in humans, and we know the data on this by personality that sometimes it's you've got those that are sort of really into the technical things that are with the gadgets and gizmos and stripping back down parts, and then you've got those that are sort of really motivated and empathizing with the individual patient, especially those that are injured. And then there's interesting where that Venn diagram can intersect. You really speak to that middle where you're motivated by both things. Did you notice quite quickly in your career that that was quite unique?
Well, there was a journalist once that said that there is a thing called the founder market fit.
Right.
And I'm happy to say that I love this space. I mean, you know, you grow with what you are surrounded with. So I think I was pretty good in, let's say, mechanics and engineering. So, you know, I did my studies between France, Greece, a bit in the US, uh, electronics, mechanics, biomechanics. All that was great. And it was, let's say, my passion. And then the clinical expertise, I'm not the clinical guy for Kinvent. We have physical therapists, coaches, doctors working with us, so
Hmm.
they know what's best. But then the most important thing is to understand your customer. And the
Right.
only way of understanding your customer, specifically a market like physical therapists, I'm not a physical therapist. I cannot just put myself in the skin of you, Jack,
Right.
but you have to spend a lot of time with them. And once you spend time, you also get the empathy because you spend time with people that love what they do, that they have sessions that are not honored, patients not coming in. Uh, they are not paid so well, but they have a level of education that is extremely amazing.
Mhm.
And so you get the empathy and you get to understand those. So once you do that, if you understand the engineering behind, you can lead the team to do the right thing.
That's right, and I think that clearly has sort of motivated your passion to retain the interest in both product and people. And so I want to get into product with you because that was
Yes.
something that when we're using your hardware, so particularly in clinic at the moment, we're every day we are using the dynamometers and the K deltas, and the way in which that is doing what you described, which is motivating compliance with patients, but also incentivizing our clinicians to better get accurate outcome measures from patients and helping them to helping the patient understand that the software is assisting with that and the user interface is fantastic. What has been the driver for you to be building the specifics of the hardware? Like, did you know where you definitely wanted to start? And then do you, when you're creating a product pipeline, like what is sort of motivating the decisions and the priorities there?
So let's give people a bit of an idea of what Kinvent is. Kinvent is 10 sensors, all of them connected to one single app called Kinvent app to assess and train strength, balance, motion, speed, explosiveness, etc. Not only assess, but also train because training is important. It's not assessment that will bring patients forward, but training. Assessment will show them where they are and where they're getting, right?
Yes.
Now, this is Kinvent generally. And among those 10 sensors, there are the dynamometers, there is the force plates, there is range of motion, speed, velocity-based training, etc., etc. Now, we didn't come up with all the 10 at once. Okay, that would be a miracle if we did. But thing is that we started with what the market was asking. So the market first was asking for tools to measure strength. Why strength? Because strength until that moment was pretty subjective in physical physiotherapy. So do you remember the Oxford scale from 0 to 5?
Yeah.
Exactly. So there was some interesting things to do there. And I mean, the professionals will use what they have in their hands. And until that moment, technologies wouldn't allow to do a strength measurement fast in a clinical setting in less than 5 minutes, right? You have to go to the lab with the PhDs, with the expensive equipment, and spend hours there and then weeks to get the results. So we tried with Kinvent to change that, to make those technologies easy to get in practice. So that's why the first thing that people asked for was strength. The second thing was balance. You have someone coming in after a surgery, and you want to simply, for example, see how they load left and right and try to work on that. And that's how we started. Force plates, small ones for balance, strength for body, for the whole body, and grip. And then just listening to what the market would ask took us to get range of motion, bigger strength, so for bigger muscle groups, then explosiveness, plyometrics, jumps, sprints, gait, velocity based training, all those things. We added them progressively.
Yeah, and I think that that's something that really makes sense then for the question of prioritizing is that you're listening carefully to what the market needs, what the patients and therapists are requiring to best enhance their treatment and their care. One of the things that's been and I'll admit now to the audience that it took for us to have the devices and to be using them and using them to good effect, but then realizing that we weren't optimizing them. Jump on a call with Athan, and he clearly shows that I was over separating tests that was actually taking. I still thought it was pretty quick because it was better than most devices we've used before. But this is the thing that you have optimized the software and the detection mechanism, especially with the K mode and things. So just tell me a little bit about that, and because that's been a really interesting way that even I thought that we were doing well, but actually we were underusing it.
So first things first is you guys, practitioners, you don't have time. So even one click more can be one too much. So we have an obsession to make the system to have as less clicks as possible. Okay.
Okay.
So it's not always easy, but this is, let's say, one of the main specifications that we put to our system, as less clicks as possible. So, but to do that, sometimes you need to enhance the technology. So you talk about, for example, auto recognition, like you go on the force plates and you do a counter movement jump, and it detects, or you do a drop jump. But on the same time, you have your dynamometers working around, and you have to be able to connect all those together. But the app should do the job to make things easy then once you finish it, so that you get your reporting. So that was a hassle, my dear Jack. And I'm very happy to say it that way, that right now it seems so simple, but
Yeah,
truly it was a huge engineering challenge to make.
I bet. I
But
bet.
we got it. I mean, for example, in back 3 years ago, there was a big challenge for us to be able to make all sensors work together, and we struggled in making them wirelessly to be synchronized. So actually, then we bought a company that knew how to do that, and
Right.
that worked out. Uh,
Right. Great.
so that's one example that allowed us then to be able to, for example, synchronize force plates with an EMG sensor, the KMIO, plus a motion sensor, plus on the side having the grip on the same time. And all those events are detected automatically. So that was a game changer for us. And I think, for you, Jack, I think it was great as well. And thanks for mentioning it because, yeah.
Yeah, well, it was something that I did. I can be called many names, but it's rarely naive. And I think with me, I was being naive in assuming that these devices needed to. Whilst it was great that they were speaking to a
Totally.
similar app, I
Right.
definitely was selecting individual tests and just thinking that I needed to wait around. So just to give
Right.
the audience a little bit of a clue as to what I'm specifically getting at here, with the K Delta force plates, I was then setting up for a series of tasks. Might just try and get an understanding of a bipedal force analysis as how they're standing, especially if someone, say a recent orthopedic patient or an ankle sprain that's overloading one side, and you want to give them some data to see that they are offloading it. They might not even realize that. So you might just do a static stand. I was then doing that test, sometimes even repeating it twice, eyes closed. Then I was resetting and doing some squats analysis to see if that pressure feedback was different under motion. And it wasn't taking forever, but I was just setting a series of tests. I had my little test battery. Under the K mode, it was then clear, and I've been using it since. It's been fantastic. Where you just then it will detect. Okay, now they're on one leg. Now they're moving. Now that it's just the ability to then just set it up and let it go, and then I just instruct and just happen to be asking the patient to do a few things whilst on the plates means that then is being measured as accurately as it was before. That
Right.
was and is phenomenal. And I think that people don't realize just how much time that can save them without compromising the amount of tests that you do. In fact, it buys you more time to be able to do more tests, and the accuracy isn't compromised. And that has been an absolute game changer. And it's something that I've been so excited to then get
Yeah.
other colleagues using, not just in our clinic, but beyond,
Right.
getting them using that.
And it doesn't stop there because then we came up with Cassandra. So Cassandra, our AI, our artificial intelligence engine that we built in the last 6 months, and we integrated in the system. The first challenge that we had is once you do the testing, then the question is, okay, so what? Now what? Now what do I do with the results? Or how do I explain those easily to my patient. And then we started thinking and thinking and trying and brainstorming. And at the end, we came up with Cassandra. So, what Cassandra does in that specific case is it takes your whole report and choose it, by the way, like you, Jack. So it actually takes all the results and builds you a prompt that you can actually change if you want. You can edit it, and it gives you a prompt that you can give to your patient straight away, which we saw it saves 7 to 8 minutes per assessment session, which is good, I suppose, for you guys. And try Cassandra out. You will be thrilled.
I think one of the things that we've been playing around with it in recent weeks, and I think that one of the things that's really interesting about it is not knowing. There's two layers to the interpretation of the data. There's one that, like, what are the variables that I want to document myself under clinical records? And then the second piece is, how do I want to communicate that to a patient without it completely intimidating them with jargon? And those layers, the AI can assist with both of those
Yes.
parts. And I think it's worth me mentioning now as well, is one of the things we've said, but just not today, is the way in which that integration, particularly with Clinico, has been fantastic. Because I think that one of the things that happened, and I was noticing with other devices historically, is that I had clinicians that were then having to sort of, they were never going to make a note of every precise detail into the CRM, sorry, into the documentation system, and so therefore they were being selectively biased with what got noted, or they're even in certain tests abbreviating without decimal points unnecessarily so, when sometimes that measurement meant that it was just getting washed out. Whereas now Kinvent app does not just give the note system everything, but it gives it enough to be able to be comparable. And that, again, it's not even in one click, it's without click, right? That is a seamless integration. That can't have been easy either. So how do you differentiate what the hardware and software tell the documentation system?
Well, first things first is you talk with practitioners and they
Right.
give you ideas. Well, the hardest part is when you have talked to 50 people and each one of those has their different opinion and you have 50 opinions. And in the end, you just have to decide. But we are pretty lucky on that because education being in that level for physiotherapists, well, it helps, right? I mean, you guys are mostly aligned generally. So that's great. And the other thing is about prioritization. I mean, Clinico is just one of the integrations we have, but maybe every month or every 2 months, we have someone proposing an integration with another system. So the question is, where do I put my engineering force? Am I
Mhm.
putting into that integration or this one? Or do I put it to build a new sensor? Or do I put it to bring a new protocol or content? So this is actually where the biggest challenge is because you can easily go all over the place and try to do
Mhm.
everything, which is not possible. But
Sure.
Clinico eventually was a good point for us because actually as soon as we started getting into the UK or Australia, lots of people started asking about Clinical. It's like a
Gotcha.
it's like on sports, it was, for example, Smartabase. Uh,
Sure.
so we decided we had to do the integration, and then what kind of metrics to show? You start by saying, okay, let's send everything, and then once you send everything, a physiotherapist might say, guys, I don't understand. I don't get the point here. I have 100 metrics. Which one should I look at? And then gradually you take
Filter.
a lot of, and you
Yeah.
end up with three, because generally three is a magic number, and because the three key metrics generally are more than let's say enough to define a test for a doctor, a medical doctor, and the patient on the other side. You as a physiotherapist, you can dig in if you want, but three generally is what you need.
Yeah, that makes sense. On the data and what it captures, one of the things I wanted to mention is that our friend and colleague Claire Minshall is a strength and conditioning coach who's
Right.
who's been on our channel many times, and on this show, has explained about the frustration that she'd had over some of the claims that were being made by hardware that couldn't measure what it was suggesting it would measure. So the things like sampling frequency, she's explained and unpacked, and I can link that
Yes.
details to this, so we don't need to go into the details of what that means in the physics of it. But people presenting force curves of which literally would not have a sampling frequency sufficient to create that. They were making assumptions. One of the things that has been shown in Claire's side-by-side testing, which has a version 2, just came into my email today, which is
Yes,
really interesting. So
a great one.
is that Kinvent's devices are measuring accurately enough to make comparisons in a much more precise way. What I wondered is when we're thinking about the pipeline and what is coming next for Kinvent, you have developed devices that, unlike other manufacturers, are not needing to then revamp their model in order to make sure that they've got accurate sampling frequencies to meet these standards of the market. So I'm excited as to where you feel, just potentially where do you think that maybe some of the shortcomings are in Kinvent's system, and what is next for you in terms of development? Are you able to give us any little clues or spoilers?
Sure. Well, first of all, to say that I'm very happy with Claire's work. Claire is one of the most objective people I met in
Mm.
judging technology. And that is something we appreciate a lot here because we believe that what we make, what it measures, should be the measurement should be transparent. We should be able to say out there how we do things because well, you know what? It's a scientific work, and we talk about people's health. It's important that the decisions that a practitioner will make are based on facts that those practitioners understand where they come from. So you talk about acquisition frequency. It's like how many times in a second we're getting a measurement from the sensor. We are at 1000 hertz or more. It depends on the application, but it was important to be able to put that kind of acquisition frequency. For example, if you want to measure rate of force development. If you
Mhm.
want to measure rate of force development, as Claire says, try to have a big acquisition frequency. 1000 is good. I mean, generally above 500 is can show you some pretty good stuff. Below, it's not that good. So it was a challenge for us to be able to get to 1000 because, you know, when we started, Bluetooth technology wasn't where it is today
Right.
because converters of signals, of electric signals, weren't where they are today. So we had to work hard on that. But at the end, you have to, I mean, you have to get there because this is what a clinician needs. So just to say that transparency is very important. Now, what comes next?
Yeah.
So recently we came up with K-Power. So K-Power is a sensor that does distance, speed, acceleration, and power, both horizontally and vertically. Today, what K-Power does is gait, sprint, and velocity-based training. Tomorrow, it will also do positioning. So
Wow.
that's one great thing. Second great thing is AI. So today we use AI for reports, for motion capture. Imagine tomorrow AI with 2 or 3 phones giving you a full analysis, 3D analysis of your human movement in your practice, not in a lab. So this is something that is coming very, very, very soon.
Wow. And if I and knowing how well these sensors integrate, am I right to assume that then a motion analysis capturing kinematic forces as you're describing it, done on the K deltas, would mean that I get the kinetic variables as well? Is that right?
You get it. That's exactly that.
Yes, that's what we're talking about. That's amazing. So
Yes.
watch this space, folks. That's amazing. I look forward to that. I can't wait to. I'm already thinking about how we can demonstrate that, and I
Exactly,
can't wait
exactly.
to get a play with that. Just on the K power, tell me how a wearable sensor also being able to measure position. That must be as how have you managed to achieve the sensitivity required for that to be as precise as I know you wouldn't let
So
anything out there if it wasn't precise for the reasons we've just talked about before.
absolutely.
You see this as a scientific problem. So how have you solved that? Because that vagueness has eluded people for a long time.
3 PhDs. That's one. That's one.
Okay.
So second is, you know, generally wearable sensors mostly based on accelerometers. Okay.
Yeah.
So an accelerometer can give you acceleration, and then with some math, You may get speed in short periods of time, like 1 second, and distance, forget it. So it wasn't enough. So we could use an accelerometer to get, for example, a range of motion or very, very short movements, but we wouldn't be able to do it in a sprint. So we actually combined accelerometers with ultra wideband technology. Ultra wideband is actually the technology people use on their iPhones, for example, when they do AirDrop or when your iPhone and your Mac know each other. So it's actually, it was enhanced by Apple in the recent years. So
Right.
it's a great technology that gives you distance. So we were able to do pretty complicated math behind it, but that's why we were able to fusion those sensors and get distance, speed, acceleration, and power. And that's how it works.
I love the fact that you've done that work because it's something that, as I say, has evaded many people for a long time now because it was something that technically, there's many things that can be done in physics because it's the art of the possible, but it's how you actually then. Is it a worthwhile exercise to actually get there for MSK professionals? That is going to be really useful, and I think it's exciting to see. And obviously I can't speak to it. I haven't tested it yet, but I look forward to getting my teeth into that.
I will give you just one example on what we
Yeah,
discussed.
please.
We talked about kinematics and kinetics. Okay, for example, change of direction. Change of direction. I mean, we talk about ACLs all the time. When does an ACL happen, an ACL tear? Is it when I do a counter movement jump? Of course not. Is it when I do a drum jump? Of course not. Right now, until now, it was what we were able to measure. But if you are able to actually define the whole change of direction movement with the torques on the knee, with the forces and the, let's say, the activation of the quadriceps, then you are able to get factors against the risk. So this is why, for example, we worked on the three-axis kinematics and kinetics. That's an example. But at the end, it's what the market needs that will drive your innovation, not the opposite.
This is the sort of stuff that is the reserve of motion labs in research tech. That is the only place, and even then they've been there's been
Right.
they've been lacking in that direction to some extent. So this is incredible that this might be accessible
Yes.
to clinicians. I think one of the things, just to give people a bit of a clue, is our rehabilitating. And obviously, I've been using only some, not all, the Kinvent sensors, but the I've been rehabilitating a female ACL, just sub elite footballer who on a kinematic variable, sorry, on a kinetic variable on the force plates and stuff, it's squeaky clean. But the way in which the on observation of movement, we can link the fact that then there's a really hip dominant on the cut. Not really trusting that knee as much as we know they can. Fortunately, this is someone that had many twists and turns associated to having been filmed before. So even though I'd only met her since her injury, the fact that we could then look across that. At the moment, I'm taking the subjectivity and the skill that comes from my analysis of her movement pre and post injury to recognize that relevant difference, and the fact that there's then both confidence and a decreased rate of force development associated to her injury post ACL reconstruction. And I'm having to link that partly because I've observed it. What Athan's describing is that the technology is going to be there for us to still be able to apply that skill, but also be able to numerate that as well and start to notice the relationship between those kinematic factors, such as a more hip dominant strategy. You might be breaking at the torso when she cuts. And the fact that I'm having to link that at the moment subjectively becomes objective as well. And we can start to then use our therapy skill to drill down on how much of this is confidence, how much of this is tissue capacity. And the art in the science means that both of those things can be more accurate. We can zoom in much closer to that, which is brilliant. I wanted to just speak to another use case I've noticed where I admittedly started to use measurement tech dynamometers many years ago and have gone from everything from an imprecise crane gauge just to pull on stuff through to the accuracy we're talking about now. I definitely thought that these things were more applicable in sporty populations. And of course, they are in many ways, they're brilliant. But rate of force development is a good example where I just assumed that that would be something where I'd be really interested in someone's rate of force development purely on a sort of tissue muscular level, right? And I thought that in athletic populations that made more sense. The more I have used it and more I've been able to rely on the precision that Kinvent have been able to provide through these sensors, the more I've realized that we don't necessarily always need to care why someone might not be getting a steep rate of force development curve and being able to generate force quickly. The underlying fact that they are, on say a knee extension test on a capable device, the fact that it might be that they're building it slowly because of pain and apprehension, rather than it being that they haven't got the capacity. As a therapist, it's still giving me that data to say we don't necessarily, we need to still unpack why,
Right.
but the fact that that curve has been able to shift over time is an important variable for that patient cares about, and that I didn't realize how many of those things I was missing, because you might get a peak torque that might show the fact that yes, they might have got to a level and be showing to be pretty symmetrical, and that they might say, yeah, it hurt, but the fact that that curve over the course of that 3 seconds was not as steep is relevant clinical information that I was otherwise missing in a patient that was not necessarily athletic. This might be an OA knee, and I had to use them to realize that, and I had to use them across the suite of my patient caseload to realize what I thought were patients that didn't necessarily need that level of precision. The precision has still enhanced my care, and I think I wasn't. That's an area where I admittedly was naive, I think.
Well, you are so right. I mean, let's take the example of fall prevention or Grandma Michelle that we talked about in earlier.
Sure, yeah.
Grandma Michelle, she doesn't want to fall. Actually, if she falls, that's a disaster because most probably she will get a surgery. So we'll spend like 6 months on bed. So Grandma Michelle is already 80 years old. So I mean, her life will change. So you don't want her to fall. Fall prevention comes from strength. But it's not just about the strength that you are able to develop in 3, 4, 5 seconds. If you are going to fall, it takes 1 second or half a second. So Grandma Michelle has to be able to react, not to fall. And that's why we're not talking about rate of force development at 100 milliseconds, but maybe at 500 milliseconds. But again, once again, it's actually the same story.
Mm. And then this is the thing, that's it's easy to be complacent and think that these are nice to haves. But once you start integrating them into your care and also seeing these exact same variables motivate that compliance with patients, that's one of the things that's been interesting. I had an interesting back and forth on social media with a friend and colleague of ours, Greg Lehman, recently about this. And it was he's someone that feels that sometimes these things can be overdetermined. But he said, yeah, one of the best arguments for it is the way in which it might motivate compliance with people. And he understood that that might be something that matters more to some people than others. And so the fact that we can do that consistently and have that reliable measurement is just something that's really enhancing our care here. And I think that being able to rely on quality hardware and software to do that is fantastic. I want to just make sure that people, if the amount of MSK clinicians that are in a position now where they're starting to think in that direction, they're starting to dabble with it, they might be realizing the limitations of some of the devices that they're using, particularly those that are like I was a few years ago, trying to use a crane gauge and just sort of pull and push on stuff and then just to get a number out that I was having to then scribble down on a piece of paper. You know, it's a start, right? And so anyone that's wanting to think in this direction, wants to understand more about what Kinvent are doing, then click the links surrounding this video. That's going to take you to our dedicated landing page. Huge thanks to Sarah, Jordan, Melinda, and team at Kinvent for working on our partnership. It's been a pleasure to work with. I'm excited for what we do for next steps because we want to start making sure we can translate, like this video has done today, some of the use cases and some of the ways in which the engineering precision at Kinvent have been able to create the accessible software, of which means that you and the patient can understand this better, as well as the fact that it applies through Physio Matters to MSK cases. And we will try and be as precise as we can to explain how that can enhance your care. So click the links surrounding this and we will be in touch with more information about how you can better improve the care for your patients and also to make your life easier in clinic, which is what Athan's team are really passionate about from their point of view. But of course, that speaks especially to Physio Matters' values. We just care about enhancing best practice in whatever which way we can. And when we can partner with companies whose values align, that's where the magic happens. So thank you so much, Athan, for your time today. Really appreciate it. Anything else you want to add before we wrap up?
Pleasure, Jack. No, keep safe and keep rehabilitating. It's very important. Okay. And keep Grandma Michelle happy.
Absolutely. It's all about Grandma Michelle. Take care, mate, and we'll speak soon. Cheers.
Bye.